Given this sequence of steps, starting at the initial list at the top and the sorted list at the bottom, it is up to us to determine which sorting algorithm was used here. There's one thing that we know about all three sorting algorithms we have looked at, and that is that in all three, there is a sorted part that starts empty and grows from one end of the list. We also know that it grows by about one element every cycle, or every iteration. The first thing to determine is whether the sorted part of this list grows from the left or from the right. If we look at the right side, you get a 4, 3 and a 4, then a 7, 5, 4. This is not the sorted half of the list, therefore the list is going to grow from the left. And then we see 1, 2, 1, 2, 3, 1, 2, 3, 4. Good. This by itself is not enough to pinpoint an algorithm, but it's enough to give us an idea of what to look for. The first three rows, nothing interesting happens. 1 and then 1, 2 are just added to the list without changing. Then, on the fourth row, we see a 3 has been added to the sorted part of the list. How did it get there? It jumped from that position, the second last position in the previous iteration. In fact, it jumped without disturbing any other elements and just swapping places with the 5. At every iteration after this one, we see the smallest element being picked out and swapped for the first element in the unsorted part of the list. The 4 and the 6, the 5 and the 7, and so on. Given that we are selecting the smallest element from the unsorted part of the list and appending it to the end of the sorted part of the list, this is selection sort. As before, the first thing to determine about this algorithm is whether it builds a sorted part from the left or from the right. Let's try the left side first. This does not look like it's building a sorted sublist. If we go to the right, see 7, 6, 7, this is the correct place. From the algorithms we've seen, bubble sort is the only one that builds on the right. That said, that by itself is not a good enough indicator. Any one of these algorithms can be implemented to build up a list on the left or on the right. We suspect this might be bubble sort, but let's make sure. The first thing we notice is that between the first and the second row, in the first iteration, the 4 and the 2 have switched spots. Neither of those is going to end up in the partial solution on the end, which is the 7. In fact, the 7 has moved 2 places to the end of the list, being swapped first with a 3 and then with a 1. In fact, we're going to see these swaps of adjacent elements all the way down. 6 moves like this to end up in its proper place. 5 moves 2 as well. 4 moves quite a bit. The 3 and the 1 switch spots, and then the 2 and the 1 switch spots. This is a typical pattern of bubble sort. We're going to begin by determining which way this solution is being built. Is it from the right? 1, 3, 1? No, it's from the left. I have 4, then 2, 4, 2, 4, 5, etc. This is very interesting. We are building partially sorted sublists on the left, but notice that the smallest element in the list has not ended up in first position yet. That won't happen until the very, very last row. This is a pretty strong indication that we are looking at insertion sort. But let's have a look at some insertions. Part of what makes identifying this particular algorithm difficult is that in the middle 4 lines, nothing happens. The sorted part of the list is going to advance forward because all the elements are where they need to be. Things get interesting when we go from the 6th line to the 7th line, trying to add 3 into its proper place in the sorted part of the list. We notice that it's 3, so we're taking the next element from the unsorted part of the list and putting it in its proper place in the sorted part of the list. We do this by consecutively pushing right these 4 elements, 4, 5, 6, and 7, without changing anything about them. This is definitely insertion sort.